Hey, this is Woodman here with another channel message. Color is a perception of light energy and wavelength that reaches the eye. The human eye can see a range of wavelengths known as the visible light spectrum, which is part of the electromagnetic spectrum. The visible light spectrum ranges from violet light, which has a wavelength around 400 nanometers, to red light, which has a wavelength around 650 to 700 nanometers. The eye contains millions of cone cells that are sensitive to color. There are three types of cones, each sensitive to a different color: red, blue, and green. When light enters the eye, it activates the color receptors that match the color. Thus, a lemon's light activates both red and green cones in the daytime, which the brain processes as the color yellow. Note that animals like dogs only have two cones as opposed to the three cones that the human eye and brain can perceive. White light contains all of the colors of the rainbow from red to blue to purple. Each color has a different wavelength, and if you add all of the wavelengths together, you'll end up with something that looks white, meaning that white isn't produced by a strictly white light, it's a combination of all the colors in the spectrum. If you shine white light onto an object and it looks green, then that means that the red and the blue have been absorbed, but the green is reflecting back. Similarly, if an object looks blue, it means that the red and the green have been absorbed, and now the blue is reflecting back. And so it turns out you can see all of the colors visible under normal light conditions, because the normal light conditions will have the entire spectrum added together, which will look white. Interesting, right? Now, what about if you take one of these older orange street lamps? These rely on sodium, and what'll happen is that you'll probably only see yellow and grayish shades. But an orange car indicator, which also is orange, is going to have all the colors. Why is that? Well, that's because there's a difference between the orange given off by the sodium street lamp and the orange given off by the car indicator. There's more than one way of making orange light. You can either make it out of pure orange light, as is the case with the sodium street light, or you can make it out of a mixture of red, green, a few yellows, and orange mixed together will give you yet another orange by combination. So just as white light is made from lots of different wavelengths, the light from an orange indicator is also made of different wavelengths. This means that when the light hits, say, like something you're looking at, the colors that are able to be seen are those which are reflected, and the ones which cannot be seen are the ones that are absorbed. And so this is possible because there are a range of different wavelengths being given off in the first place from the car indicator. So although the two types of light both look orange to us, they are in fact very different because they were made in very different ways. One being from pure orange, and one being made from a combination of colors that resulted in orange. The conclusion, therefore, is that we really can't be sure that the orange we're looking at is a true orange unless we try some sort of experiment to isolate the wavelengths, which then will let us know whether it is composed of multiple wavelengths or it is just a single pure instance of that wavelength that gives that color. What about a beach ball under sunlight? Let's go through the steps involved in seeing the beach ball. Notice all the colors in the beach ball. They come from different paints in the plastic. Light is made from different wavelengths, and white light, obviously, as I mentioned, is a combination of all of them. When a ray of white sunlight hits a patch of beach ball, the paint absorbs most of the wavelengths. It reflects the rest. Thus, for example, if the patch we're looking at is blue, then it reflects the blue wavelengths and absorbs the red and the green and so forth. Those reflected light waves from the sun bounce off of the beach ball and right into your eye. That is when the action starts inside your body. At the back of your eye is a tissue called the retina. The retina has these special cells that are called rods and cones, and they live in the retina. These cells are the eye's lookouts. Their job is to spot light and let the brain know about it. Different rods and cones react to different wavelengths, which are correspondingly different colors of light. When light hits the rods and cones, they send electrical signals to let the brain know. They do this through the optic nerve. Like roads and highways, nerves carry signals around the brain and the body through their various pathways. The optic nerve is connected directly to a part of the brain called the thalamus. Like cards and packages arriving at a sorting station, signals come into the thalamus from many senses, not just sight. The thalamus processes those signals, combining and repackaging some of them into new information. Then it sends the information to other parts of the brain. Next, the information about the beach ball heads to the visual cortex. It's an area way in the back of the brain that is part of the occipital lobe. Special cells in the visual cortex are on the lookout for different kinds of visual information. For example, some of those cells react when the object is a circle. Others react when it is a line. Some cells react to motion, some react to color, and some to various other things. So when it comes to seeing the ball, specific cells recognize the color, and other cells recognize the shape and the way it is overall depicted. These signals are combined, and then they create an image in our brain that we can understand. Information about the beach ball's image heads out along the nerves to other parts of the brain. One place it goes to is an area in the front called the prefrontal cortex. The prefrontal cortex is behind the forehead and above the eyes. That's where brain processes information from the senses and combines it with other kinds of information, such as memories and emotions. In other words, obviously, at some point there may be some sense of recognition. Maybe we've dealt with this kind of information before, or there's some similarities, right? Together, all this information helps us to make sense of the object. We see the beach ball's round shape and all of its colors. We can tell which direction it's moving in. We can tell its motion. We can understand how hard it is to hit it, to send it into our friends' waiting hands, and we know when to put our own hands up in the air to catch it. For us to perceive the beach ball, so many different parts of the brain have to work together seamlessly and very quickly, right? It's as they always say, think fast, right? So what we've learned here today is that really when we see colors, we're not necessarily really seeing the color, we're seeing the absence, right? In other words, whatever is reflected back is the absence, right? So if we see blue, we're reflecting back blue, and everything else is being absorbed. So really, it's we're getting all the rest into that particular region, and what's being reflected back is what we believe we're looking at. So because the blue keeps getting reflected back, we believe we're looking at blue. Because the yellow keeps getting reflected back, we believe we're looking at yellow. If the white gets reflected back, we believe we're looking at white. And in addition, we may not know exactly how the light that is shining on it is affecting it. Because as we saw with the sodium street lamps, if we're looking at a beach ball with all these various colors, under a street lamp, we may just see a bunch of shades of orange and yellow and gray, and not much of anything else. We know that there's differences. We can see that the colors look different, right? And that's where the gray comes in, right? Because it might be a lighter gray or a darker gray, but we really can't sense more beyond that. We can't tell that it's red. We can't tell that it's yellow or green, because that information is being lost because we're looking at it under a sodium street lamp, which really only projects orange. If you enjoyed this message, please like, share, and subscribe. If you're new here, thank you. Welcome aboard. This is a safe space. Welcome to the channel. If you're returning, thank you so much. I love you so much. You keep this channel going. In the name of the Most High God, I wish for health, wealth, prosperity, and abundance, peace, blessings, and protection upon you and your loved ones. Woodman signing off. Have a great day. Take care.